Okay, let's start with question number one, A. And basically, question number one says to write the reactant products, including the physical state, and then use the coefficients to balance the equation. So we got here, right? Um, Sodium hydride. Anyway, sodium is a type 1, and hydrogen, when it combines with metal, is -1. But it says the formula here, and it's solid plus water, right, produces hydrogen gas plus sodium hydroxide. Now, let's balance, make sure, and by the way, let's put the state. It's added to water, right? This would be liquid water. If not, it would say vapor. And this is gas, produces gas, and this is aqueous. So you write AQ as aqueous. Okay, so AQ, that's AQ. Mhm. Now, you got here, right? Let's balance it now. So you got two hydrogen, one sodium, I'm sorry, three hydrogen, one oxygen, oxygen, one sodium, sodium. It's already balanced. So let's go with the next one, letter B. Okay, letter B, it's aluminum metal reacts with aluminum metal reacts with chlorine gas to form solid aluminum chloride. Okay, to be able to write the products we need and the reactants, we need to understand the charges. Hold on for a second. Okay, so to be able to write it down, how I was saying, you need to know how to write down a name of a compound and the charges. So aluminum metal, which is doesn't have a charge, is by itself and it's solid, reacts with chlorine gas. We need to know that chlorine is one of the ones, the elements that exist as the atomic atom, like a gas, the atomic molecule. Sorry, the atomic molecule, and it's gas. Okay, hydrogen gas, nitrogen gas, oxygen gas, to form solid aluminum chloride. So it's aluminum chloride. Now, what is the charge of aluminum? Aluminum is a a type 1, and the charge is +3, and chlorine -1. We cross multiply them, and it's gonna be 3 and 1 here. So it's AlCl3 and solid aluminum chloride. So now let's balance it. Should be good if I, hold on. And now we got aluminum chloride and we're gonna balance it. So it's gonna be aluminum is balanced already. It's gonna be 3 chlorine and 2 chlorine. So let's go and find a common denominator, right? And it would be 3 by 2, 6, 2 by 3, 6. And then we have to rebalance again the aluminum. And that's it. Next one. Let's start with the problems, the stoichiometry problem. Usually, um, molecules and Avogadro's number, um, you don't need to use them. That's the reason why in chemical reactions, and usually it's not given conversions between molecules, atoms to moles. Now, what you have to have clear that always this chemical reaction, the equation is a representation of the reaction, but in terms of mole. It's like a language. This is the recipe, and the language is moles of molecule, moles of atom. So no, you cannot use molecules to do the stoichiometry ratio. You cannot use, well, you can use it, but you have to divide. You're gonna get molecules on the other side too, and a big number. So take it to moles and grams. You cannot use it. It's a different language, definitely. So here you got, is it balanced? Yes, it is balanced already. So it says that you have 1.5 by 10 to the 23rd H2 molecule. By the way, you can use molecules, right? Because both you're going to divide it or multiply, and it's the same thing. But this is what happened. It's moles. What happened, let me tell you the difference so you understand something. When you use molecules and atoms here, it is going to be the same because the conversion factor is Avogadro's number. So if you multiply all by by 6.023 molecules or atoms, it's going to be the same. But the difference, why can you not use grams? Because the molar mass are different. So for example, if you're doing the limiting reagent, use a moles. It's going to simplify because if you look at grams, for example, it could be very misleading. Because if you have hydrogen, for example, and you have nitrogen, and you get 1 mole of each one, you say, oh, okay, 1 gram of each one. Ah, okay, it's a 1 to 1. And but it depends on the molar mass. Or this example, 1 to 1, and you say, okay, none of them are in excess. No, one is going to be in excess. Why? Because if you have 1 gram of hydrogen gas, it's going to be divided by twice the molar mass of hydrogen, which is 1.0079. So it's going to be 1 over 2. And fluorine has a molar mass of 18. By 2, it's like about 32. So here you have much less amount of moles in the case I'm not telling you of grams. But let's go back to the problem. So we got here 1.1 by 10 to the 23 hydrogen molecules, right? And what do? Let's convert it first to mole. So how do we convert it to mole? Dividing by Avogadro's number by n. That is usually a capital N. So we divide 1.5 by 10 to the 23rd. And look at your flow chart. From molecules to moles of molecule, you divide by Avogadro's number. You divide by 6.02 by 10 to the 23rd molecules per mole. As I said, I got all those calculations ready, but if I made a mistake, you just double check. You need to double check just in case. And this is gonna give me 0.249 moles of hydrogen. I'm not gonna round it yet until we get to the end. Moles of H2. Of H2. So now we got the moles of H2. Now what do we need to do? The ratio, stoichiometry ratio. Use our recipe to determine, because they're telling you here that you got how many moles of HF. They're asking for the moles of HF, hyd hydrogen fluoride. If it's a gas, if it's an aqueous solution, would be hydrofluoric acid. So here you got how many? 0.249 moles. Now understand this. This is a 1 and this is a 2. This is the recipe, right? So when you put this over this, you do the cross multiplication. You put how many moles of this you have? 1 mole of hydrogen. You see, you put the recipe on top. You put the equation on top. 1 mole of hydrogen gives me, according to the recipe, 2 moles of HF, of hydrogen fluoride. Now let's go to what we really have, what we need to calculate, because this is what it's saying, but don't have 1 mole, you have less. So you need to recalculate how many moles are you going to get for 0.249. So here you got 0.249 moles of hydrogen. And how many would I have then? So moles of hydrogen and moles of hydrogen cancels out. So how do we calculate? We cross multiply. What I mean that is on top, on bottom, on top. If it's here, it goes down. If it's here, it goes up. So X, let's leave it by itself, and it's going to be 2 moles. We already canceled the moles of hydrogen of HF multiplied by 0.249 divided by 1 because that's the one that it's up here. So this means this is going to give us 0.4983 moles of HF. But now we have to take it to the right amount of sig figs. And how did we start it? What is the only that gave us the number of molecule? And you know that the exponential doesn't count, so it's gonna be the digit part only. So it's gonna be here 2 sig figs. So X would be 0.550 moles of HF. 50 has 2 sig figs because the 0 after the decimal after a number, a number, it's significant. Not before, not the leading. Okay, so it's 1 to 0.50 because you round it and you get 0.5. In fact, you round it here, right, and it gives you 0.5. Okay, let's go to the next one. Hold on. Let me put a pause and let me redo that because I gave it to you not balanced. Okay, let's keep on going. I deleted the coefficients. So let's start with balancing the equation. We need to balance it. Be careful. If you did it without balancing, it's all wrong. So you got here N2H4, okay? And gives me nitric acid plus H2O. Now let's start balancing the nitrogen. 2, okay? Now the hydrogen, you got 2 and 2, 6. 2 and 2 plus 2, 2 plus 4, 6. 2 plus 4, 6. Let's go ahead and look at, we have the nitrogen, 2 and 2. We have 2 plus 4, 6. 2 plus 4, 6. Now let's go ahead and balance the oxygen, and that's the one that is going to give us a lot of problem. 6 plus 2, 8. You see? 4 plus 2, 8. But we got unbalanced the hydrogen now because we got 8 plus 4, 12. 2 plus 4, 6. So let's not touch the nitrogen, let's touch the water. So let's go back to the hydrogen here. Why do I not touch the nitrogen? I could too. I could. Let's keep on going like that. Let's see if we change the water. 2 by 2. 4 by 2, 8. Plus 4, 12. 2 plus 5, right, is going to be 2. 5 by 2, 10. Plus 2, 12. 8 plus 4, 12. 8 plus 8 here. 6 plus 5, 13. Doesn't work like that. So again, let's go and find something that is going to make it possible. So 2, 2. Let's find with 6 to see what happens. The next one here in water. That's going to be 6 plus 6, 12, 8. So what if we put a 6 here for the oxygen? 12, 12. But let's look at the hydrogen. It's going to be off. 12 plus 2, 14. 12 plus 4, 16. So we have to go to 7 now on the water. I'm not doing it around changing everything because I already have balanced the nitrogen. So the only thing that it's equal to two of them is hydrogen and oxygen here. So if you got 7 by 1, 7 plus 6, 13, it's not going to work out. 7 by 2, 14 plus 2, 16. I know I have here 4 plus 12, 16. 2, 14 plus 2, 16. Oxygen 12, 6 plus 7, 13. Let's put it at odd number now here on the water. Uneven. Sorry. Let's get rid of this. 8 by 2, 16. Let's go with the oxygen. 2 by 3, 6 plus 8, 14. So what do we need to have here to get a 14? 7. So 7H2O2. So nitrogen, we didn't touch it. That's why I didn't want to get into nitrogen. So nitrogen is okay. Because if I start touching this nitric acid, then I have to change this one and then go back and recheck it. So the better way to do it is that when you got these two, work with the water only to see if we can make it balanced without touching this one and this one, which contains the nitrogen. Two and uh, 2 and 2 nitrogen. Okay, let's go with hydrogen. 16 plus 2, 18. Okay, nitrogen, 2 nitrogen. Hydrogen, let's go with hydrogen. 16 on the left, sorry. 14 plus 4, 18. 2 plus, this is 16, it's going to be 18 hydrogen. Now let's go with oxygen. 14 oxygen here. And on this side, oxygen, you have 6 plus 8, 14. Here we got it. This is the balance equation. Okay. I put it in brackets, so no. What I'm going to do is delete this one. Okay, we got it now. Now we start working with it. You can't do it without balancing the equation. So hydrazine and hydrogen peroxide have used in rocket and they react according to the equation. How many moles? How many? They're asking for the moles of nitric acid. Nitric acid are formed from, I thought I pronounced it nitric, but it's nitric acid, how you should pronounce it, are formed from 0.2, 0.0250 moles of N2H4. So, what do we have to do? We have it already involved. There's not a problem. So let me do my ratio thing, my cross multiplication. What are they giving you? The moles of NH24. So it's 0.0250 moles. And they're asking for what? For the moles of nitric acid. So again, you have here the recipe. So you write that one mole of hydrazine gives you 2 moles of HNO3. You really got 0.0250 moles. How many moles of nitric acid would you get having this amount? So it's going to be again this up moles of NH2 with hydrazine moles. By the way, the hydrazine, how do you name it? It's dinitrogen tetrahydride. Okay. So we got here 0.0250, no moles because we cancel it out, by 2 moles of nitric acid divided by 1 mole of hydrogen, by 1 because we already canceled the moles of hydrogen, how I said. So this is going to be, of course, 0.050, 0.0500 moles of HNO3. Now let's look at our sig figs for a second. 1, 2, and 3. 1, 2, and 3. So this is the answer. Okay, let's go with letter B now. How many moles of hydrogen peroxide is required if 1.35 moles of H2O are to be produced? So let's go back to our equation. They're giving you 135 of water, and they're asking for the moles of hydrogen peroxide. So again, looking at our equation, right? Let me see if I can copy and paste this for a second. Okay, yeah, but good. So here we go, looking at our equation, the only difference we have here is that now we have 135 of water. They're just changing 135 moles of water. But if you know one, the rest of them, this is different from letter A, but the same equation. So what are they asking for the hydrogen peroxide with this? It doesn't say it very H2O2. 7 moles of hydrogen peroxide is going to produce me 8 moles of water. How many moles of hydrogen peroxide would I need to produce 1.35 moles of water? You see why I like it like that? Because you're thinking, that's me. For example, I'm telling you what I'm doing. Like how many moles of water these produce this, how many would be? So moles of water and moles of water cancel out. And then you get x equals 8 by, hold on, it's 135 by 7 divided by 8. Because you get this up, this down, and this up. So it's 7 multiply 7 moles of H2O multiplied by 1.35. Remember, the moles of water was cancelled out. So 135 moles of hydrogen peroxide divided by 8. And that gives me the moles of hydrogen peroxide. And it's going to be, X would be 1.18 moles of H2O2. Now, by the way, I already gave the results in 3 sig figs. 1, 2, 3, 1, 2, 3. You probably going to have more numbers on your calculator. You just have to take it to that. Now, how many moles, right? How many moles would I get? Let me see what they're asking now. How many moles of water will be produced or formed if 187 of nitrous F? Do you see what they're doing on this problem? They're trying to get you that if you have one, you can get the other one. If you have another one, you can get. If you only have one, you can get everything on a chemical equation. Because their equation is giving you everything. So if you just to have one is enough. Now another story is when they're giving you two and both are the reactants, because then you have to calculate the limiting reagent. So 7 moles, again, I put my equation on top, right? And this is gonna be, because that was the other one. So they're giving me 187 moles of nitric acid, and they are asking for how many would I produce of water. So it's gonna be 2 of nitric acid moles of HNO3 divided by 1.87 moles of NHO3. Or how I said, 2 moles of NHO3 are also going to produce 8 moles of water. If 187 moles of HNO3 of a nitric acid is produced, how many moles of water? So it's going to be, again, 8 moles of water. And then we cancel out again this. Multiply by the 187 here, divided by 2. And that is going to give you, how I said I have those numbers calculated them already. It's going to give you 7.7 point, and I didn't calculate it, 7.48 moles, and it already has the sig figs include moles of H2O. Remember, you have to be cautious about the sig figs at the end of the problem, and it's three again. It's 3 sig figs. So the problem is in 3 sig figs. The other two. Let's go ahead with number. Let me see how many minutes we have. Let's go ahead and do letter D. Okay, the last one. How many moles of hydrogen peroxide? Again, I'm going to copy and paste, and I'll finish this video and start posting them. And so we got here, right? It's asking how many moles of hydrogen peroxide, now you know you have to put the X here, will be required to react, and they're giving you the hydrazine 448 moles. So again, I do my cross multiplication, and it's going to be 7 moles of hydrogen peroxide are going to give me 1 mole, because there's not a coefficient is 1, of N2H4. Of N2H4, hydrazine or dinitrogen tetra. So moles of hydrazine and moles of hydrazine cancel out. And this is going to give you, again, X goes here on top. And then here, you go 0.448 on top. No moles because we already canceled it out. But this one, yes, 7 moles of hydrogen peroxide. And that's what they're asking for. Divided by 1. And this is going to give us 3.136 moles. 3.136 moles of hydrogen peroxide. And listen here, right? Here you got 1, 2, 3, 4, 6, and the problem, I don't need to go back to up to, you can see it, but see, they're giving us 3, 6 fix, 0.448 moles of hydrazine. So our answer should be 3, 6 fix, 3.4 moles of H2O2. Now I'm going to stop this video, post it, and in the meantime, I'm already working with the next one.